Welcome. In this presentation, we will review linear regression, understanding linear regression with the caret package in R. Linear regression is a fundamental statistical method that models the relationship between a dependent variable and one or more independent variables. Today, we'll explore how this method, coupled with the powerful caret package in R, can not only predict outcomes but also play a pivotal role in statistical testing. Let's delve into the definition of linear regression. It models the linear relationship between the dependent variable and independent variables with the linear regression equation. The goal is to estimate the coefficients to make accurate predictions. Now, why should we use the caret package? The caret package in R simplifies the process of modeling, training, and evaluating machine learning models, including linear regression. It provides a unified interface and makes our tasks more efficient. Let's go ahead and install and load the caret package. Let's start by loading and exploring our dataset. In this case, we're using the famous MTCR's dataset, focusing on the MPG, DISP, and HP variables. Exploring the dataset structure helps us understand our data better. As with any data analysis, we need to handle missing values responsibly. Let's perform some simple data processing, starting with handling missing values in our dataset. Our next step is to check for outliers. Outliers can significantly impact our model, so it's crucial to identify and address them appropriately. Let's visualize the box plot to identify any outliers. Having identified outliers, it's time to remove them from our dataset. We'll ensure that our dataset is clean and ready for modeling without the influence of extreme values. To evaluate our model, we need to split our data into training and testing sets. The training set helps the model learn, and the testing set assesses its performance. Let's create these sets. With our data ready, let's proceed to train our linear regression model using the train function from the caret package. This step involves fitting the model to the training data. Now that our model is trained, it's time to evaluate its performance. We'll make predictions on our test data and calculate the root mean squared error, RMSE, to assess how well our model predicts. With the model trained and evaluated, we can make predictions on new data. Visualizing these predictions allows us to compare them with the actual values, providing insights into the model's accuracy. Moving into a more advanced topic, let's explore a statistical testing example. We'll define hypotheses for the overall significance of the linear regression model and the significance of each individual predictor variable using the MTCR's dataset. In hypothesis testing, the null hypothesis, H0, assumes no significant relationship, while the alternative hypothesis, HA, suggests a significant relationship. Let's formulate these hypotheses for our variables DISP and HP. To perform hypothesis testing, we need to conduct tests for overall model significance and individual variable significance. This involves analyzing p-values, which indicate the probability of observing results as extreme as those obtained if the null hypothesis were true. When interpreting p-values, values below the chosen significance level, often 0.05, suggest that we reject the null hypothesis. This implies statistical significance, indicating that the variable or model has a meaningful impact. Let's dive into the practical aspect with example code. We'll load the necessary libraries, load the MTCR's dataset, and fit a linear regression model to predict MPG based on DISP and HP. Now, let's conduct the hypothesis test for the overall significance of the model using ANOVA. This will provide us with insights into whether the entire model is significant. Continuing with our example, we'll conduct hypothesis tests for each variable's significance using summary and extract the coefficients, standard errors, and p-values. To make the interpretation more accessible, we'll explain the significance of each variable based on their p-values. This step helps us understand which variables contribute significantly to our model. In conclusion, this code example fits a linear regression model, tests hypotheses for overall and individual variable significance, and interprets the p-values. Adjust the variable names and dataset according to your specific data. As we conclude, let's recap the key concepts we've covered today. Linear regression serves as a fundamental method for modeling relationships, and the caret package enhances its efficiency. We've explored essential steps in model training and evaluation. We've also touched upon hypothesis testing in linear regression, emphasizing the importance of p-values in determining significance. I encourage you to further explore these concepts and apply them to your own data. Thank you for joining today's presentation on understanding linear regression with Caret in R.